So we're going to talk about this water trough problem. So pretend like you have this water trough that looks something like that. And we've got dimensions here. We know this length is 3 feet. We know the width up here at the top is 12 inches. And then we have this parabolic shape right here. Okay? So all those things are going to be important for what we want to do. Now, this water trough is going to fill up with water, depending on, how much it rains or whatever the runoff is. It might go all the way up to the top, but maybe it doesn't go up that high. Maybe it only goes part way up. Maybe there's not that much rain or something. What we want to be able to do is figure out the surface area. So pretend like it's full. Oops. Pretend like it's full up here. And you could figure out the surface area for that rectangle. There's a rectangle there. You could figure that out because you know the dimensions. But what if it's not full? Okay, so then we need to look at this parabola. All right, so I'm going to draw a little parabola here, and I'm going to center it at the origin. Now, it's going to be a parabola of some shape there. They tell us it's a parabola. We don't have to guess. But what we know up here is that is 12 inches. Okay? Now, we talked about the parabola in the last video and how it's not a one-to-one function. So when we want to talk about the inverse, then, we're kind of in trouble. But what we can do is we can look at just half the parabola. So we're going to look at this half right here, the positive case, and that makes some sense. And we're going to think about this point right here. Now, if it's half the parabola, then we know this distance here is 6 inches, right? Okay. And we know it's a parabola, right? So this is like x and y that we could figure out. So this is 6 here. So I know I have my function y equals, now we don't know the stretch factor. We have it centered at the origin, so we know we don't have a vertical shift or a horizontal shift, but there could be a stretch factor and we don't know what that is. So ax squared. But we know that, let's see. Oh, we know the height, right? We know this height here is 18 inches. So, right up here, that's 18 inches. That probably doesn't look right. It's this distance here that's 18 inches. Okay, that might look a little better. So we know that when x is 6, y is 18. That's an ordered pair that we know. Hopefully that works for you as far as x and y goes. So we know that's a point on the parabola. In fact, it's that corner point right there, 6, 18. This allows us then to figure out a. So if y is 18 and a is, we don't know, 6x is 6, we get 18 equals 36a. And if we divide both sides by 36, we get 1/2 equals a. Now we have a function. We know y equals 1/2 x squared. Okay? Now, what we're trying to figure out, though, is the surface area based on the depth, how deep the trough is. So we want to know, we're going to know how deep it is, and we want to figure out the surface area. We're going to know y, and we're not going to know x. So to do that, we're going to look to find the inverse of this function, and so we're going to solve for x. So if I multiply by 2, let me multiply by 2. And then I get, if I take the square root of both sides, plus or minus the square root of 2y equals x. But we're not going to be using the plus or minus because it wouldn't make sense to have a negative number for our x value. So remember, our x value is going to be this distance from the center of the parabola out to the parabola, that distance there. And so we're not considering the negative case. Okay, so let's try to put this all together then. We have the original function for the parabola right there. And this is for when x is greater than or equal to 0. Okay? And then we have the inverse where we've taken that and we've solved for x. And we have this equation x equals the square root of 2y. And again, we're only looking at the right side of the parabola. If you're looking at the y-axis, the right side of the y-axis. Now, how do you figure out the actual surface area? So I talked about this earlier. We said, well, if it's all filled up, that makes a rectangle, and we can just go, the area of the rectangle is going to be length times width, right? The length of this rectangle isn't going to change. So we don't have to worry about that. But the width, well, if it's full to the top, you know the width is 12 inches. If it's not, then we have to base it on how deep the trough, how deep the water is in the trough. Now, this says 3 feet for that length of the trough. That's going to be 36 inches. So we need to keep our units the same. All right, so we know the length is 36. And then the width, well, it's going to be this piece. Let's see, I need another color. It's going to be this piece, but there's going to be 2 of them, right? So remember when we said, oh, it's 6 inches to the right. Well, it's 6 inches to the left. And so it's going to be 2x. It's going to be times 2x. All right. And that would tell you, if you knew what x was, it would tell you then the surface area. And you might say, well, why do I want to know the surface area? Well, you know, you've got animals that are going to come and drink from the trough, and you want to know how much surface area they have to get their water. Okay, so then this makes 72x. But remember, we don't know what x is. We have to use this in place of x. So it's going to be equal to 72 times the square root of 2y. Now if I know the depth of the water in the trough, I can figure out the area, the surface area for the animals to drink at based on that y value. Okay? All right, so notice that when we have a parabola and we had, what was our original function? 1/2 x squared. And then when we found the inverse, it was a square root function. So this was a quadratic, this was a square root function. Remember, we had to restrict it because it was not 1-to-1. So we said, well, when x is greater than or equal to 0, and then that was the same thing over here. Y was going to be greater than or equal to 0 in that case too. And I think that's all I want to say on that problem.